All right, we're going to do a little bit more around this process of converting from standard form to vertex form. So we're going to use the process of completing the square to write the quadratic function in vertex form, and then from there we're going to determine the vertex, domain, range, and maximum and minimum of the function. So the main difference in these examples is that we have a leading coefficient that isn't 1, and of course to complete the square that has to be 1. So when we were solving an equation to complete the square, we were dividing both sides by whatever that leading coefficient was to get rid of it. We're going to treat it a little bit differently here. So the first example we have is f of x equal to negative 3x squared plus 6x plus 1. So again, it doesn't really serve us to divide f of x by negative 3, right? So I really want to do whatever I'm going to do to the right-hand side only, but I want to employ completing the square as well. So what I'm going to do, I have to factor negative 3 out just from the first two terms. So here I go. I've got negative 3 times the quantity x squared minus 2x quantity plus 1. So I'm leaving the constant at the end outside of this factoring process. Okay, so I just factored negative 3 out from the first two terms, right? So if I were to distribute the negative 3 back through there, I would get negative 3x squared plus 6x plus 1, right? What I started with. So now that I've done that, I'm going to complete the square, right? I'm going to have x squared minus 2x, and I'm just going to complete the square on that piece. So negative 2 divided by 2 squared, right? So 1 squared is 1. All right, so I have to add and subtract it. Now, I put parentheses around all of that, right? Because you're adding and subtracting inside the parentheses. And then add the one outside, like so, right? Okay, now, I use the big bracket parentheses because now I want to think about factoring that perfect square trinomial there. Okay, so here's what I'm going to do. I'm going to have negative 3 times the quantity x minus 1 quantity squared, right? So negative 1 minus 1 is negative 2, right? Negative 1 times negative 1 is 1. So that works. X minus 1 quantity squared minus 1. I still have that minus 1 in the parentheses plus 1. Okay, now I'm going to distribute that negative 3 through. So I've got negative 3 times the quantity x minus 1 squared plus 3, right? So I distributed the negative 3 both to the binomial squared that I had and also to the negative 1. Okay, and then don't forget about that plus 1 off on the end. Okay, so just to further clean this up, I have negative 3 times the quantity x minus 1 squared plus 4. Okay, so what's the vertex of that? The HK value right there is 1, 4. Okay, the domain, it's a quadratic, right? So the domain is all real numbers, negative infinity to infinity. And the range, okay, now hold up here because the leading coefficient is negative 3, right? So if it's negative, that means the parabola opens down and we have a maximum point there. So the range would be negative infinity up to, what's the y-coordinate of the vertex there? 4, right? So that gives us the set of all y values there. Okay, and then it says, what is the maximum? Okay, the maximum is simply the highest y value of the function. Don't list it as a point, just list it as an actual y value. So a maximum or minimum is a y value. Now let's look at r of x equal to 2x squared plus 3x plus 5. Same story as what we did over here. We've got a factor just out of the first two terms here. We're going to factor out 2. Okay, so we have x squared plus 3 halves x plus 5. Okay, let me slow down a minute. When I factored the 2 out of the 3x, what did I do? 3 isn't divisible by 2. Whatever, and this could go even if it is divisible by 2. You can think about what is that coefficient divided by 2. So, and if you think about this, if you distribute 2 back through, right, you're going to have 2x squared plus 3x, right? Because the 2's will cancel when you multiply it by 3 halves. Okay. All right. So now, yes, we're going to complete the square on that stuff in the parentheses. So we got x squared plus 2 times the quantity x squared plus 3 halves x. Okay, what are we adding to this? We've got 3 halves divided by 2 squared, which is 3 divided by 4, right? 3 halves times 1 half squared, which is 9/16. Okay, so we're going to add 9/16 and subtract it inside here. So now, bring out the other style of parentheses here. I got to factor just this piece in here, right? So the square root of 9/16 is 3/4, right? So I'm going to have x plus 3/4 squared, right? Minus 9/16 inside the parentheses plus 5. Here we go. I have to distribute the 2 through, so I'm going to multiply it times my binomial squared. Don't distribute through there, just multiply it outside there. We're going for the vertex form here. And then 2 times 9/16, that'll give us minus 18/16 plus 5. Okay, so 2 times x plus 3/4 squared. 18/16 is 9/8. And get a common denominator there. So with 8, I'm going to have 40/8, right, is 5. So then we'll have 2 times x plus 3/4 squared. Negative 9 plus 40 is 31/8. Okay, so our vertex is negative 3/4, right, because we're adding inside the parentheses, and 31/8. Okay, the domain is negative infinity to infinity, right, because it's a quadratic. Now the range, the leading coefficient is positive, right, so it opens up, which means it's going to have a minimum, and the range is going to go from 31/8, we're including 31/8, up to positive infinity. Okay, and what's the minimum, right? This has a minimum in this case because it opens up, right? And the minimum y value is 31/8, right? So you kind of take that minimum or maximum value from the range, right? Okay. Also, I encourage you to go to Desmos and graph these, see if the information on the graph matches what we found here in terms of the vertex and what you're seeing of the domain and range and maximum and minimum respectively.